Let's go to Kai first, and then we'll go to David Senecal, who has a terrific slideshow. Kai's got something technical. Go for it, Kai. I'm going to spotlight you.
Okay, I'll do. Just lower my hand.
Go for it, Kai.
Okay, I want to talk about turning soft metal on a wood turning lathe. And I started doing this to make kind of little ferrules that I put into my wooden handles for bits so that I can exchange them. They are just held with 2 screws, and that's the result, and it's all done on a wood turning lathe. So that was the first try. And then as I like doing spinning tops, I thought, well, would it be possible to turn a spinning top out of metal? And I tried that as well. First, I just made the shaft or the handle from aluminum rod that I got from a DIY store in Germany. And also this little part on the pull string I made as well.
Excuse me, Kai, what do you mean by soft metal?
Mainly brass, aluminum, so non-ferrous metals. They are rather soft compared to iron.
Thank you.
Right. So that was aluminum. The first try, I basically just rounded the ends here on the lathe, and then I turned some small spinning tops from brass as well. And I can show you how I did these brass spinning tops. I hope the video is going to work.
Yep, it's good.
Yeah, okay. So first, I use a scraper for doing this. I'm working on center and pull it along very slowly, and you get quite nice shavings. The point of contact between the tool and the metal should be rather small, so that keeps the tool or the workpiece from chattering. After doing the
Do you have a burr on that? Do you have a burr on that scraper?
Yes, there is a burr on the scraper. So it cuts better with a burr. It will cut without a burr as well, or scrape without a burr as well. But with a burr, it's sharper, works better. And if you have a burr on the scraper, you have to use the tool hanging down a little bit so that you actually get the burr to cut.
But you're cutting right at center, right? Looks to me.
Yeah, then you have to have your tool your tool rest a little bit higher so that you can kind of slope down your tool a little bit and then get on center line again. That's right. Yeah. So just watch the shavings that are produced. And you can work from left to right and the other way around without using too much pressure, because otherwise you get chattering. And here is a nice kind of shaving that developed. And the tool is HHS steel, so ordinary steel doesn't work that good. And then I use a smaller miniature turning scraper now to get more into the curve, which I couldn't do with the big scraper. And you see it isn't as sharp as the other one. I should have sharpened it. And then I swap the tool for a straight-handed scraper to do the shaft or the handle of the spinning top. And it's made from 8mm brass, which is 5/16 of an inch. Then I realized I had to sand the spinning top because it's rather thin now, and if you make it thinner at the shaft, you will get vibration. Please excuse my hair in the picture.
What are you sanding to? What grit?
I think that was 800 that I used there. The surface was rather nice from the tool already, so I used a really fine sandpaper for the tip. For the shaft, I think I started with 240 because I wanted to sand the transition between the round part of the body here and the shaft. The straight-ended tool here left a little step, and I wanted to sand this away. So if you have to remove material, you want to use sandpaper that is a little bit coarser. And if it's just for polishing, you can get away with the very fine sandpaper. Maybe I forgot to stop it again. Yeah, with this, I also tried not to have the whole tip touching the workpiece, but I angled it a little bit. So that is not at a right angle to the shaft, but it's angled a little bit so that mainly this corner here does the scraping or cutting. Then you get less vibration. The surface is a little bit rough, but there's less vibration. If you want to try something like this, it's nice if you've got one of these collet chucks, because you can work near the chuck and it's not dangerous. You won't hurt yourself if you touch the chuck. Yeah, that's where I used the coarser sandpaper, so I think that's 240 now. And my hair again in the picture, sorry. And in the end, I polished it using kind of household polish that you use for brass or silverware. And that gives a really nice shiny surface.
Lovely.
And maybe you can use that technique for making little knobs for boxes or things like that as well. So it's, or maybe a tip for a spinning top, not the whole spinning top.
What speed are you turning at?
Between 1000 and 2000 RPM. So when it's really thin, you can increase the speed a little bit.
Yeah, it's really little.
Yeah.
You think it would be the same if I was with like a 1-inch rod? Same, it would work as well?
Yeah, yeah. I made these tool ferrules from 15 millimeter rod. That's a bit more than half an inch. And I think if you lower the speed a little bit, it should be working with bigger rod as well.
No. Mike Peace had his hand. Mike, you got something you want to add to this or ask about it? You're muted, Mike.
You're muted, yeah.
Spacebar wasn't working.
Still isn't.
Would you say that lathe speed again?
Between 1000 and 2000 RPM
Okay.
I used for that. So you can start at a low speed and then increase it a little bit, see whether you get away with that. Normally, chatter is no problem because the workpiece is really small. It's just trying out where you get the best cutting action. And with a thin piece like that, the speed can be rather high for metal, I guess.
And were you using regular M2, or did you say you needed exotic like M42 or V10 or something?
No, it's just an ordinary HHS scraper I used. And the brass, I don't know the composition of that. I just got it from the scrapyard. So
one piece that I played around with, I had a bunch of brass knobs left over from a kitchen redo, and what I found was the outside was hollow, and you could pull it off or knock it off or something, and the bottom of it was this very nice solid piece that you could make wonderful little pulls or feet for boxes or something. So if you have a kitchen redo project and you replace the brass knobs, you got a lot to play with.
Yeah. Did you use scrapers as well for working them?
Oh yes.
Yeah. Yeah.
I remember learning how to turn copper rod in school, but I guess copper is pretty much the price of gold these days.
Yeah.
I think the reason that you're having so much luck with scrapers is that if you're turning brass or copper in an engine lathe, you actually grind a -5 degrees rake into the tool. And if you have a positive rake, it'll grab it and rip it right out of the chuck. So actually pointing your scraper downhill may be the reason that it's working so well. Also, if you want a ferrous metal that is machines about like brass, there's a screw machine alloy called Leadloy AX, and it will machine just about like brass.
Yeah.
Bert, you got something to add here?
Yeah, I was going to say I've done that with brass where I had to make some soft feet for a set screw. If you put set screws and stuff, you put it in and mars the shaft. Well, I tried to find some set screws with a little brass or a nylon end on it, and they were difficult to find. So I just made some, and I just used same technique that Kai's showing there. I used high-speed steel, made the little insert, drilled the set screw out, and glued the brass tip on the set screw. And now I don't mark any of my tools when I run a set screw in anymore.
Yeah, that's a good idea.
And I can make as many as I need. I don't have to go looking for them. I think I've made a half a dozen so far. And it takes a little time. And the first one was an experience. But once you do it once, you learn and you move on.
I used copper sheet once to make a segmented bowl where I put thin copper between the wood, and glued it with super glue. The piece is still together, so it worked. But it's like, when you really think about it, if you're riding at a reasonable speed, it actually works quite well if you combine the metal and the wood together in a piece. Well, it did for me anyway.
Mike Prezzo? You're still muted. You're still muted.
Here, I'm unmuted now. I've actually done some cold rolled steel. I made some. We had Cindy Drozda. I had hosted her in a hands-on years ago, and she had some of the inserts for the one-way live center that Wayne Campbell out in Vancouver makes. And I just turned the basic taper and using high-speed steel that I buy at Busy Bee here, and I have them mounted in either 1/2 or 5/8 bar stock for turning wood, and just substituted them, and it was pretty crude, but it worked. And sometimes I finished off with a file, but I was able to do a little bit. I could show them sometime.
Cool. John Chalikian.
Yes, Kai, could you use carbide tipped tools? Did you try that?
Yes, I guess you could. I tried a homemade one with a carbide insert that I got from China, and that works as well. But I found the scrapers with a burr work even better than the carbide insert I used. So the carbide insert is great for plastics or acrylics and stuff like that. But with the brass, I found that the scraper works better. And I just used my ordinary scrapers that I use for bowls and boxes. So it's nothing special you need to have there.
Have you got more slides you want to show, Kai? Or are we at the end of
I can show the rest of the video a little bit, and then two or three more slides.
Okay.
And that's it then.
Good.
Yeah, I'm really interested in the tool holders that you made. That's a great idea.
Yeah, I took some photos of the process, how I made the tool holders as well. Maybe I can show them another time if you're interested.
Yeah, we'll have that another time. Let's finish this off, and then we've got a great slideshow coming up.
Okay, just so that. I broke it off then, the spinning top when it was very thin, and that's the result.
Wow.
Wow. Wow.
Okay, so and then just try to go on. So you can see it's spinning. It's not exactly the same top as I showed in the process of making it. It's another one that I made as well.
That's spinning on glass or mirror.
Yeah, it's a mirror.
So no friction, no appreciable friction.
Yeah, and also it spins quite long because it's got more mass than a wooden top of similar dimensions. At least if you don't use very, very heavy wood. So cherry or something wouldn't spin that long.
I know.
And I find it's getting more interesting when they lose speed, because then they move a little bit more. These
It's going to break your mirror when it lands, right?
Yeah, or is that small? Doesn't matter.
Sometime I'd like to play that in very slow motion, and as you're doing now, and see how it. Yeah.
Yeah. With tippy tops, it's interesting to watch it in slow motion, how they turn around on the top then. Okay, so just go on. And that's the one with the aluminum handle, where I kind of shape the tip and the end of the handle here. And I've got a little video how that works as well. It's very short. So that's the rough saw cut here, and it's not straight. That's why you get some chatter in the beginning. Of course, you could put a file to it first, but I was too lazy to do that. And you can turn or straighten the aluminum as well. The shavings are not that nice as they are with brass. So brass is the easier metal to work.
I see Doug has his hand up, and Doug knows a lot about aluminum.
Yeah, it's just 2 or 3 more seconds, and then this is over. And then maybe, yeah, okay. Yeah, yes, Doug?
Well, I just want to make 2 comments. Somebody made a comment about carbide tools, and I think Ernie alluded to it earlier. The reason that they may not work as well isn't because of the carbide, but because of the angle that's used on the tip, it's the carbide scraper. You often see a much sharper angle than you would associate with metal turning, because carbide is clearly used for metal turning and every day, and that's why they developed them, because wood turning isn't that big an issue. The second part with your aluminum, you're right about that one, but there are some aluminum alloys that are designed more for machining than others, and so they will chip very differently. So when you buy it, for example, if you go into the store and they get you a rod that's 1100, for example, it doesn't machine very well. But if you get an alloy like 6061, it's designed to make machining and doing that. So it makes machine a lot better than this one does, Kai.
Yeah, okay. I just got that from the DIY store, and I don't know about the composition. And what I realized is these rods that you get from the DIY store in Germany, they are not totally round. That might have to do with the production process. I think it's kind of an extrusion process. So they're
probably extruded. Yeah,
it is extruded to make the stuff as cheap as possible. You have to run it through an extrusion press, and even though the die is round, if you don't draw it or something like that, it's never quite round when it comes out.
Yeah,
you're an engineer. You can figure that one out. So anyway, which do you want, cheap or round? That's the question.
Okay, I take what is available. That's sometimes the problem.
Figure it out from there. Yeah,
you figure out what there. But anyway,
yeah, it works in the end. It works. Yeah. Okay, and maybe just the last slide. So to sum that up, non-ferrous metals and alloys, as for example aluminum and brass, can be turned or scraped on a wood turning lathe using ordinary HHS tools. With a burr, they work better, and the contact area between cutting edge and workpiece should be small to avoid vibration. Lathe speed between 1000 and 2000 RPM. At least that's what I tried out. Maybe you can get away with very small workpieces and higher speeds as well. And what I didn't write down here, you should work on center line, so the tool hanging down a little bit. So you have to adjust your tool rest this way. Okay, that's it. Thanks a lot.
Thank you, Kai. Terrific slideshow.
Wood shop. Thank God for wood.